So today we'll be discussing about the Aldol condensation. So you check some prominent examples. So the example before we have before us on Aldol condensation is the butanol and propanol. When in our previous class, when we talk about Aldol condensation, it deals with the reaction it deals with the aldehyde and the ketone reacting with a dilute base or acid to produce our beta hydroxy ketone So today we'll be looking at two distinct examples. The first one says butanol and propanol. So now as you all know, butanol is said to be an aldehyde. Butanol is a common example of what of an aldehyde. So you have it as this. So this is our butanol. So that is butanol undergoing an Aldol condensation reaction. So to give us this, so we make use of our dilute base, sodium hydroxide. So now the first step here is that for every Aldol condensation, we need to locate the alpha hydrogen. That is, we need to locate the presence of what? Of an alpha hydrogen. So the moment there's a presence of an alpha hydrogen, we form our enolate. So now let's bring OH. You can split our sodium hydroxide as usual, and we have OH what? Minus. So then this OH minus attacks our alpha hydrogen at this point, and which leads to what? Deprotonation. That is, to deprotonate our alpha hydrogen, and we are left with this. So we are left with this. Sorry. So you can also have it in this manner. So you are left with this. You can see there have been a deprotonation of what? Of our alpha hydrogen, and we successfully form what? Our enolate, which is, when we talk about our enolate, it is said to be what? Very active. And one of the most common uses or common application of our enolate is to form carbon-carbon bond formation ring. That is, to form a bigger and more complex structures. So now if you successfully form an enolate, so it has the opportunity to bond with other carbon to form more or bigger or complex carbon chain. So now the next one, as this is our first step, is what? Deprotonate our alpha hydrogen with our dilute base. So the next one is what? The moment we form our enolate, so since we deprotonate, an enolate is being formed during the process. So the moment we form an enolate, since it is Aldol, we only deal with one reactant. The moment we form our enolate, we introduce the same reactant. So you can see we want to introduce the same reactant into the equation. So introducing the same reactant, our butanol again, we have CH3, CH2, C double OH. You can see. So we introduce the same reactant into the equation. So the next thing is that our enolate would attack. You can see it will attack the carbon. We will attack the carbonyl carbon. We can see our enolate successfully attacking the what? The carbonyl carbon, leading to the formation of this. So we end up having this, which we end up having this. So it causes, so the moment the enolate attacks our carbonyl carbon, so which causes what? The delocalization of pi electron. There's a delocalization of pi electron, which we have the double bond is being erased. We have a single bond with oxygen carrying a negative charge. This is to show that is the presence of what? Excess electrons. There have been a delocalization of pi electron, which is to show that the presence of what? Excess electron. So now the next thing is that we've been able to, one of the most the reason we are doing this is to form a possible connection, to form a possible linkage that which reactant A and reactant B can eventually what? Link together. So with this we form an active site that can make the enolate and our second reactant to form a carbon-carbon formation ring. So now the first thing is to add this together with what? With this. We link them together. So leading us to the formation of this. So when we lead, let's start from here. CH3, CH2, CH2, CO minus and H. So we can see this is this way. So what is the next thing? We need to introduce our what? Our knowledge. The next step is to what? To introduce our knowledge to the equation. And don't forget, our knowledge has a very more complex shade. So in our knowledge, we have a very more complex shade. This is it. You can see before this is the alpha carbon, alpha, our beta, and our what? And our gamma. So we can see our alpha, beta. So and the point of connection is this carbon. This is the carbon we want to connect. And to get this possible connection, so we need to form a branch chain. You already know. So let's start with the carbon to connect. So we have C, H, and we have a respective branch chain, which we have CH2 and what? CH3. So with the aldehyde group, then we are left with C double bond OH. We can successfully link the two reactors together, giving us a carbon-carbon bond formation what? Ring. So the next thing is we can't just leave this. We can't leave it like that. The next step is to hydrolyze. So we hydrolyze our reactant by bringing in H2. So in simple terms, we have to split to undergo cleavage. We have H plus and what? OH was minus. So we add H plus to our equation. You can see it is being added. So the next one leading to the formation of this. So you can see this is our product. So this is our product. This is our product. So now let's try and name our product. We have this is our product. You can see we've successfully gotten our product. So this is our normal. This is our beta hydroxy ketone. So we've gotten our beta hydroxy ketone. So the next example before us under Aldol condensation is we need to consider our propan-2-1 that is undergoing on Aldol condensation. So these are our structure for propan-2-1. Which is a ketone group. So undergoing Aldol condensation. We bring in our normal base, dilute sodium hydroxide. You have Na plus and OH what? Minus. So we have now the first step is that let's locate our alpha hydrogen. That is our alpha hydrogen. So we can see it is being balanced. We can decide to pick at this point. We can decide to pick at this point. So let's just go for the one at this side. So attacking this carbon. So which will lead to the protonation of what? Of alpha hydrogen. So we are left with this. So H3C we can see the protonation has occurred, which leads to what? To the formation of what? Of an enolate. And this eventually we can see that if any form of enolate, and we are just whenever you talk about Aldol condensation, that is, you are only provided with just one reactant. The next thing is to what? Bring back same reactant into the equation. So you might have it like this, or two might be added. So these two means you are going to be using the reactant twice. So there are some situations where two might be added in front of our reactant. That is, you have to make use of the reactant twice. So now since we form our enolate in the first step, bring back the reactant, and we are left with this. So we bring it back. You have H3C double bond O. So then this our enolate would attack the carbonyl to attack the carbonyl group, so leading to the localization of pi electron. So we eventually form this, eventually form this. So the next one is that, so since we form this and if we form this, the next thing is what is to add the enolate and this together. We add this and this together. We need to add it together. And why are we adding it? That is to form a carbon-carbon linkage, to form a carbon bond formation, to form a carbon-carbon bond formation. So that's the reason why we need to add A and what and B together to form a bigger and more complex structure. So when we add it both together, we have this. And this CH2 C. So we can see we successfully add both of them together. So the next thing is what is to introduce our water molecule H2O. So the moment to introduce our water molecule, the O negative here to be erased, and H plus comes in. We have H plus and OH what minus. We can see here. So the O negative, so H plus comes in. We are left with this H3C and COH, CH3, CH2, C double bond O and CH3. So you can see we successfully form our beta hydroxy ketone. So we form it. This is our product for Aldol condensation of what? Of propan 2-on.